Hello, my name is Daniel Platt, and I'd like to give you an idea of what to expect from this course. Are you frustrated with Nginx? I know it can be hard at times. Sometimes it helps to have a starting point, something that you can modify that is close to what you want to better suit your requirements. This is why I created this course. It's about showing you what's possible with Nginx. After all, Nginx is much more than just a web server. I'm going to show you how I've used Nginx in some simplified examples, but they're based on real-world applications. You're free to use them in your own setup, or better yet, combine some of them. I hope to see you on the course. Hello, my name's Daniel, and I'd like to welcome you to my course. This course is about showing you what is possible with Nginx. After all, Nginx is more than just a web server. I won't be explaining every concept of Nginx. I'll leave that to another course. Though I will explain what I use. I hope that you already have some experience with Nginx. If not, you may struggle. But feel free to reach out. These examples will be complete, and you can use them in your own server. Sometimes it helps to have a starting point that you can change to better suit your requirements. I'm going to show you how I have used Nginx in some simplified examples, but they are based on real-world applications. You are free to use them in your own setup, or better yet, combine some of them to make something even more awesome. I'll see you in the next lecture. Before we get started, and we start talking about operating systems, we need to know where you're going to be running your creation. If you just want something that's free, and you don't mind dealing with installing the computer, then you can use VirtualBox. VirtualBox is free. You can install it on Windows, Mac or Linux. If you use VirtualBox, you won't be hosting on the internet and nobody else will be able to access it. If you want somebody to be able to access your creation, I recommend a VPS, and I personally use DigitalOcean. There are others, but for cheapness, they're great, and their support is pretty good. I think I've only accessed their support a couple of times in the last few years. It's mostly because they've got great documentation. In the next couple of lectures, I'll show you how to set up VirtualBox and DigitalOcean if you want. Let's move on. The internet isn't a safe place. Passwords are being brute forced, accounts are being hacked. It's not safe. So how do you connect to a server securely? What I use, and what most people do use, is something called SSH. And they use SSH keys instead of passwords. This is a lot more secure than just having some 8-character password or even a 20-character password. Instead of taking years to crack, would take centuries to crack, if not longer. So for this reason, let me show you how to generate an SSH key on a Mac or Linux. If you're on Windows, you need to use something called PuTTY, and I'll put in a link in the resources. So all you need to do is open up your command prompt, your terminal, and type in SSH keygen. And what that will do is it will generate your key pair. It will tell you where it's saving it. You just press enter. And in my case, I've already done this, so I don't want to overwrite it. When it's finished, you'll have these key pairs. And they will live inside your .ssh directory, inside your home directory. Let's make that a bit more obvious. Gosh. And you can see there, I created my SSH keys back in 2012. And what you'll need to do is you'll need the contents of your public key. ID_RSA is your private key, and ID_RSA.pub is your public key. The idea is your private key you keep 100% safe, you don't reveal it to anybody. Your public key, you can give it out to everybody. and they use that to verify that you are you based on some challenges they do between the two keys. So it's pretty secure. So what you'll need to do is view the contents of your public key, and in a later lecture you'll need to copy and paste that, and we can add it into, say, DigitalOcean or another server to allow automatic login. I'll see you in the next lecture. For my online hosting, I use a company called DigitalOcean. Their philosophy is very simple. They give you the raw computing power and then you build something awesome on top. And that's reflected in their pricing. The ones I will be looking at are the standard droplets. And depending on your needs, you can pay as little as $5 a month, or you can pay as much as you want, have as many servers as you want. But for this course, I'm going to focus on the $5 a month one, which with the free credit, if you use my referral link, you can have at least a couple of months free without having to pay anything. And when you're testing, you don't need to spend a lot. But when you're in production, it might be that you need a little bit more oomph, a little bit more memory for caching, or more cores to enable your application to handle more traffic. But we can talk about that later. So you're going to want to sign up, but I already have an account, so let me log into mine. So I'm going to assume you have an account, and when you log in, this will be what you're greeted with. So the first thing you're going to want to do is create a droplet. And you want to make sure you're choosing Ubuntu 16.04. And we'll scroll down to the size, and for this purposes, we're going to choose the 1 GB, $5 a month. We don't need to worry about block storage. And for data center, you need to choose the location that's closest to your customers. I'm going to leave it on London. Additional options is great. You can have backups, which, as it says, it adds 20% to the monthly droplet cost. And it takes a backup once a week and retains the last 4 weeks. So it's pretty handy if you want to roll back. For these purposes, I'm not going to enable backups. However, I recommend that you consider it, and certainly if you're in production. For IPv6 rather, you don't need it. However, if you add it, it's a lot easier than adding it later. You don't have to take advantage of it, but if it's enabled, then at least you're assigned an IP address. Don't worry about user data. And I would recommend you turn on monitoring, because it gives you some nice metrics about the CPU and memory utilization. SSH keys. With these servers, there are 2 different ways you can authenticate when you log in. One is with a username and password, and unfortunately most people know what the username is, which is root. So it could just be a matter of time. You can get around it by creating a second account and disabling login to root. However, what I like to do is use SSH keys. They're a lot harder to guess, in fact nigh on impossible, but you do have to look after them. If anyone gets your private key, then it's kind of game over. They can log into anything, you can. So I'm going to show you how to set up SSH keys on this server, which also has the nice side effect of disabling the password login. So we'll do new SSH key, and in here we just need to paste in your public key. So let's get the one we generated earlier. So we copy that, paste it in here, and give it a name so you remember which one it is. You can also edit your account to store your SSH keys, and next time you create a server it'll just appear here and you can just tick it rather than pasting it in every time. In this instance, we're only going to want one server, so unless you're creating a whole load of servers at the same time, just leave this one as one droplet. And hostname, you can leave it as blank, or you can treat this as the reverse domain name. So if someone was trying to find the IP address and the hostname associated, this would be what would be resolved. So you can type in a full domain name here. This will only benefit you if you set your domain name to point at this server. And you can also add tags if you want, whatever you want to help you filter on the dashboard. So, and you just type it in, hit enter, and then hit create. And there you go. My server, my IP address, and if you click into it, we can just click on here, you can actually see everything about it. So if you want to turn it off. Snapshots is a good one. It's like backups, but you are in control of when you take them. So if you're going to do anything that you're not sure about, you can take a snapshot and you can always roll back to it. And that's it for this lecture. During this course, I'm going to be using DigitalOcean. However, if you don't want to use DigitalOcean, you can use any other provider. As long as they provide you with a VPS with root SSH login, then they should be compatible. That said, there is also a free alternative. It won't allow you to test online, and certainly won't allow you to use Let's Encrypt that we're going to use later if you want HTTPS certificates. But if you just need it for local access and you only need it running on your computer, then there's something called VirtualBox. And you can download it from VirtualBox. So let's do that. virtualbox.org. So you click download, and then you choose the host you want. I'm on a Mac, so I'm going to download the macOS version. If you're on Windows, then this is the one for you. And that's just going to download the installer. Whilst you're here, you might as well download this extension pack. It just makes it a little bit more compatible with the drivers. Okay, they're now downloaded. And they'll come down as an installer. You may have to unzip them, you may not. It kind of depends on your platform and your browser. But on the Mac, this is the executable. So we'll just go through the motions of installing this. There shouldn't be anything to customize. It's pretty much everything on. In fact, it's everything on. And we just authenticate. And this is just going to install it for us. It shouldn't take too long. And that's it done. And we don't need the installer anymore. On the Mac, there's another step you may need to do, which is to authorize the extension. And all you need to do is it will appear in here as Oracle is requesting access, and there'll be a little allow button. So you press that and it'll be able to continue its installation. And we just need to install this extension. All we need to do is double click that and it should open up VirtualBox for us. If it doesn't, you may need to sort of drag it into the application. And this is asking me to upgrade because I've already had it installed. But yours will probably say installed rather than upgrade. So if we do that, and we just need to read the terms and conditions and then click agree. And there we go. VirtualBox is installed. In the next lecture, we'll talk about how to install the operating system into this. Previously, we installed VirtualBox. Now let's create our first virtual machine. I'm going to call mine Ubuntu machine. It's very unimaginative. VirtualBox is trying to guess the type of machine I'm going to be installing. It's kind of guessing Mac, because Mac is in machine. But we need to choose the type of Linux. And there we go, it's got Ubuntu now. The preference is for Ubuntu 64-bit. And then we'll just hit continue. And we're going to use the same defaults as DigitalOcean. So it's 1 gig of RAM. Let's create a disk. It's going to be dynamic because if we don't use it all, then it doesn't matter. And I believe DigitalOcean is 25 gigabytes. So we hit create on that. Now we need to quickly go into settings. And the first thing we need to do is we need to download the ISO for this. We go to ubuntu.com, we click on server and download Ubuntu server. And then finally actually download it. And there you go, the ISO is now downloading. Whilst we're waiting for that, let's do some other changes. Under audio, we don't need it. Under networking, we need to change that to bridged adapter. And this just means it's going to share your network card and it's going to appear as if it's directly on the network. You need to pick the network adapter that your internet connection comes into your computer. If it's Wi-Fi, then you choose your Wi-Fi card. If it's Ethernet, then you choose your Ethernet port. If it doesn't work the first time, you can always come back into this and change it later. Great, so the ISO is now downloaded. And what we need to do is make sure we're selecting our CD-ROM drive. It's virtual, so it doesn't matter. And then there's a little CD icon that we can tell it which file to use. And then you just navigate to your downloads directory, select it and tell it to open it. And that is everything you need to change in the settings. So you OK that, and let's just click the start button. And your virtual machine will start to turn on. This install is going to be slightly different to the DigitalOcean one, but it's mostly because DigitalOcean will have customized their install to remove a lot of the extras that Ubuntu server may come with. And they may have added a few extras of their own. Alright, the first thing we're going to need to do is choose the language. So you need to give the window focus. So then you click on it. And then your arrow keys are how you move around. And then you just press enter when you've got the right one. And you just press done again once you've done this. And we're going to be installing the bare bones Ubuntu. We're not going to worry about cloud or clustering or anything like that. And we're going to use DHCP for our IPv4 address. And you can see up there what your IP address will be. If you use a proxy to connect to the internet, you'll need to enter it here. But if you don't, you can just skip this part. And for this, we're going to use the whole hard drive, the whole disk that we created. And then you can see it's got virtually 25 gigabytes. And let's click done again. And we need to make sure that we're happy with this. So it's double checking. So we can just hit continue. It's just warning about data loss. But because it's a new hard drive image, there's no data to lose. So it doesn't matter. So the install is going at the moment. You can see it copying at the bottom. But it wants to create an administrative user rather than the root user, which is different to the DigitalOcean way. You can choose whatever you like for the server name. It's kind of like the reverse lookup name that DigitalOcean gave us. Because no one's accessing it, it doesn't matter. So I'm going to just call mine Ubuntu. And then I'm going to give the username Daniel. And then we'll just put a password in there. And then we can click done. Finally, click reboot. And then press enter again to say you've removed the disk. VirtualBox will remove the disk for you. You're going to have to do it every time if you want the CD image to stay there. And now the virtual machine is booting back up. And when it's done, we'll be able to log in. Oh, don't know what that is. You can just press enter again to bring up the login screen. Logging in is a simple matter of remembering the username and password you set. So, mine was Daniel and password. And there you go. That's you logged in. You can log in this way, but I find this terminal a little bit clunky. You can't resize it as much as you want. Copy and paste is a bit hit and miss. So what I recommend is logging out of this. Obviously, take note of the IP address, which you can see there, and we also saw earlier. In fact, actually, we don't even need to log out. And load up your terminal. And what you can type is SSH, your username at 192.1. Because we've never connected to this virtual machine before, we don't know what its fingerprint is. The fingerprint is a computer's way of identifying remote servers. So let's just say yes, because we know for sure that this is the right computer. And now we just need to type our password in. That fingerprint thing will only come up once, unless it changes. And there we go. You've got a much better terminal right here. To get to the same state where we are with DigitalOcean, or where we will be in a later lecture with DigitalOcean, what we want to do is enable us to log in as the root user. So the first thing we need to do is become the root user. And we do that by typing sudo -s. Sudo is just super user do. -s is for a shell prompt. And we just need to enter our password again. There you go, that's the root user. And if we look inside here, sudo doesn't change our home directory. So what we need to do is change into the root user's home directory. And let's have another look at the directory structure. So in here is a .ssh folder. And if we go into that, what's in here? There's an authorized keys file. And what we need to do is we need to paste our public key in there. So I've got my public key in the clipboard. And then we just paste it in. And then we just press Ctrl X and then Y and then enter to save. Now, when we log out and then we try to reconnect as root, it's using our public key to authenticate with our private key. And we don't need to type a password. And that is where we will be with DigitalOcean. So if you see me connecting to DigitalOcean as a root at IP address, then you just need to type these steps, which is SSH root at and then your local IP address. I'll see you in the next lecture. Now we have set up the operating system. We need to move on to setting up Nginx. By default, Ubuntu won't have installed Nginx, Ubuntu 16.04 has an old version in the apt repository. But if you're using 18.04, then at the moment you're running the same stable version that's currently available on nginx.org. Regardless of which version of Ubuntu you're running, I would recommend using the Nginx PPA. A PPA is just a way of overriding the apt repository to tell it where to get some software from. The Ubuntu version will only have some security fixes applied, whereas the Nginx PPA will always have the latest release in it. First, we need to add the signing key to allow Ubuntu to verify the authenticity of the Nginx packages. If you don't add the key, then Ubuntu will complain with updating from such a repository can't be done securely and therefore has been disabled by default. So let's connect to the server. Clear the screen. And what we need to type is apt-key adv, and then we tell it --fetch-keys, and then we give it the path http nginx.org/keys/nginx_signing.key. Don't worry too much about copying these down. I will put a file in the resources that you can just copy and paste from. And then we hit enter, and you can see it's imported the key quite nicely. Now that we have the key, we can create a file that overrides apt to tell it where this PPA is. So that's in etc apt, and then it's in sources.list.d. And we're going to create a file called nginx.list. And in here, we're going to paste 2 lines. And we're going to need to replace codename. And this is just the codename for the version of Ubuntu you're using. So I'm using 18.04, which is Bionic. If you're using 16.04, I believe it's Xenial. And again, I'll put this in the text file for you. And then we press Ctrl+X and then Y and then hit enter. And if it all goes to plan, when we do an apt update, it will download from this. So this is just doing an update of all the apt repository information, as well as the Ubuntu stuff. So somewhere along here. And there you go, you can see it's checked the nginx.org. We can just type apt install nginx. And that would be it done. However, in one of the examples, we'll need to access the GeoIP information, and that requires a module. So we might as well install it now. So that is called nginx module GeoIP. There you go, that's installing. And whilst we're here, we might as well load the modules for it. Otherwise we may forget later on. And we can just paste these at the top. And the last thing we need to do is start Nginx. So we can just type service nginx start. If we type in our IP address 192.168.1.136, there you go. That is our Nginx welcome page. If you don't see that, then double check your settings. Now that we have Nginx working on Ubuntu, let's move on. Installing PHP is beyond the scope of this course. I'll give you a quick idea of how to install it. Connect to the server. What we need to do is add the PPA. And now we need to do an apt update. And then we would do apt install PHP 7.2-fpm. And now we should have PHP installed. There we go. And now you'll have PHP ready to use for when you need it in the examples later. For a couple of projects, we're going to need something called Composer, and it's a PHP dependency manager. And I quite like it. So what we need to do is get Composer. And the URL is getcomposer.org. All we have to do is copy and paste this PHP code. Let's connect to the server. And we paste it. And finally. So there you go, you've got composer.far. And I like to move it to USR local bin, and we'll call it Composer. Oh. Got the actual file to move, and there we go. Unfortunately, I don't think we have any path variables set up. Or do we? Hey, cool. So now you can just type Composer in whichever directory you are, and it's available globally. You also can type self-update in the future, and it will keep itself up to date. Well, every time you run it, it'll update itself. So that's how you install Composer. I'll see you in the next one. When you're building websites or maintaining websites, sometimes you're going to want to move a site from one server to another. And you can do this. It's easy. You download the contents and upload it with the database. Not a problem. But how do you know that the new site in its new location is working perfectly? Maybe you've missed off a PHP extension, you've not configured Nginx correctly, that sort of thing. What you can do is you can tell your computer to override the IP address that you get from DNS. So when you make the request to your new site, you're going to the new server rather than the current server. And that's fairly straightforward to do. So on Linux, the file is called etc hosts. You have to be root to do this, so if you're not root, you'd need to do sudo. And in here is overrides. And this is just sort of a default file for your internal networking. I would leave whatever's in there alone, but you can add to it. So how does this work? Well, let's take Google for example. Google's IP address, in this instance, happens to be this. So let's override that. So what we do is we type the IP address we want it to be. I use tab because it helps to keep everything a bit more organized. And then you just type the domain name. You can type more than one domain name here if you want, but for this purpose, we're just doing one. And so we come out of that and save. And now, when we redo this, you'll see that the IP address has changed to the IP address we've overridden. And I hear you thinking, but I'm not on Linux. Okay, on the Mac is exactly the same thing. And I know most of you are not going to be on the Mac. But, and there's me doing a local website on my local address range. On the Mac it's slightly different, so you do that and then you have to flush the DNS. And that is different depending on which version of the Mac OS you've got. So Mac OS flush DNS. This is a good one because it's got all the different versions of Windows and Mac OS. So that's going to be the one you need if you're on Mac OS. What I'll do is I'll put this in the the resources. And obviously on Windows it's different again, but not too different. On Windows the path is C:\Windows system 32 drivers etc host. So you can see that Microsoft have kept the etc host part, but they've just hidden it away in the system32 directory inside the drivers directory. And you will need to be an administrator to do this. So when you open Notepad, you need to open Notepad with administrative rights. And again, I'm going to link you to a document that tells you how to do this for Windows. So before you put a website live, double check it works and use your host files to help you do so. In this section, I'm going to show you different Nginx configurations, but I'm only going to show you a handful of websites. The idea is to show you what you can do with your own sites, rather than how to set up lots of different applications. And just because I show you one way of doing something, it doesn't mean that's the only way you have to do it. You can even combine some of these ideas together. You can even combine lots of these ideas together. Let's move on to the first example. Do you have a few domain names that aren't currently being used? If you do, then why not create a holding page for them? Rather than letting your DNS provider claim all the money. If you don't have your own holding page, the chances are you've left it as default with your DNS provider, and they have got a page on there that potentially makes them money. Why don't you do it for yourself? Promote your own business, and if you wanted to, you could put ads on it. What we're going to do is create a holding page that tells people they've reached the right location, but the website is currently offline and being developed, and maybe offers a method to get in touch with support. This scenario is the most basic setup. So basic, in fact, that this is the Nginx default configuration. You can think of it like this. The internet comes to your server, and regardless of the domain name, gets shown the same website. Now, if you have another website defined, then that will get shown. But this is just undefined domain names. However, the default Nginx page isn't very exciting. It's more of an advert for Nginx than anything. Editing this page is as simple as changing the files in USR share Nginx HTML directory. So let's have a quick look. So we'll connect to the server. We'll go to that. We'll change the directory into /USR/share/Nginx/HTML. And there you can see there's an index file. That is that same page. Now, if you want to make a good holding page, you're going to need some HTML and some images and some CSS. So that's something I can't provide you with, but I can give you an idea. So I've got my own copy of that directory. And I've got the index. I've also got the 50x error page. I can give you a copy of this, but that's what it looks like. It's very basic, but it looks a hell of a lot better than the Nginx default page. So all we need to do is copy these files up. And that's just a simple matter of finding an SCP client that can upload the files for you. On the Mac, it's CyberDuck. On Windows, it's WinSCP or FileZilla. So let's load up CyberDuck. And what we need to do is we need to connect it to the same server. Put it into the server. Importantly, we need to use SFTP or SCP or something that says SSH File Transfer Protocol. And we give it the root, and we need to give it our private key. wherever it's stored on your computer. And then click connect. And there you go, you're on the server. So we need to go to that same directory. USR, share, Nginx, and HTML. And all we need to do is copy up those files. Yes, we're going to have to overwrite them. And then you're done. And then when you refresh the page, there you go. So how is that working? Well, if we have a look at the config, which is in the etc nginx directory, and inside this conf directory is a default.conf. And this just tells Nginx to serve that file. And if it encounters any 500 etc errors, it will display the other one. So you could put a more of a twist on it if you wanted to. Sort of like an error has occurred. But until you set up any other domain names on this server, in this block, this is the one that's going to be chosen because it's the only one. We can encourage it by saying, because otherwise it's going to be a race condition, it won't know which one to pick. But if we use the underscore, we can say that this is the one to use. We can also say up here, default underscore server. And this will tell Nginx that this is the exact one that we want that everyone to have until we specify a server name that matches ours. But that is all we need. You can do service Nginx, reload. And this will also work for the IP address as well. So anything that hasn't been configured. So paste that in there. And there you go. The only change I will make is I prefer everything to be under var ww. So if we change that, in fact, because the www directory itself doesn't exist, we'll create it. And what we can do is we can then say everything in that, what was it, Nginx, HTML, and then we'll move that into this directory. I just find it a little bit easier to find. So at the moment, if you do that, there's no files, it can't do anything. If we reload, then it's all working. So from this point onwards, I'm going to be using var www directory. I'll see you in the next example. In the last example, we created a holding page. But maybe instead of creating a holding page, you change the default to a maintenance page. What's the difference, I hear you ask? The main difference is the holding page, we probably don't care if it gets cached by a search engine. It's probably a page on a website that you've never had before. You've just bought the domain name, don't know what to do with it, just point it at your server, and then don't worry about it. However, a maintenance page more than likely shouldn't be cached. It's an existing website, you've gone down, you've got a problem, but you want to tell the search engines this isn't your actual website, we're having problems, we'll be back in a minute. That's what the 500 errors are for. Let's have a quick look. So server errors. A 500 is an internal server error. It suggests it's a good enough error code for us. There's a problem, and the idea is that Google won't cache it. If you said return to 200, which is here's the website, then Google's more likely to cache that. So I already created a maintenance page as part of the 50X. All we need to do now is a little bit of Nginx config, then we're up and running. The HTML is good enough. So like before, we want the domain name to be catch-all. You would never have the holding page and the maintenance page on the same server, unless you put the server names directly in it, because you can't have both being a catch-all. Only one will be able to take precedence. So we want the same root, we need the same redirect, but what we actually need is we need to be able to say anything that matches /, we need to return our 500. Anything else, then we need to match it. We need to see equals to be absolutely matching. So we'll modify this one because we need the same try files. So we're telling it's a regular expression, but we also need to say it has to start / dot to match anything, and again, one or more characters. So that'll match anything but the /. In this case, we're not worrying about default file, so that also means we can get rid of this middle one, because we don't have an index. And one thing I will change about this is we might as well keep all these error codes, but I also want to tell it that when it returns this error, that we want it as a 500. And so if we just reload, now any URL should throw us off as a down for maintenance page. And we can double check that with terminal. So if we copy that URL, load up terminal, and if I type curl-v to give us more information, we scroll up, and there we go, we can see in there the internal server error. So that should tell the search engine that we're having problems. And that's it. I'll see you in the next example. One way you could speed up a website is by moving all of its assets, images, movies, CSS, to a CDN, a content delivery network. But if you want to do one yourself, we can do a simplified version. This isn't a complex CDN. That's the kind where you have geolocation, serving assets from servers that are local to those users, though you could do with multiple servers and some DNS hacks or the right DNS provider. However, there's going to be some benefits to this setup, even though it's simple. It's going to simplify your Nginx config, because all your assets just need to be in one config file, your application one could be in another one. And it's easier to cache. If you use separate domain names, and by this I don't mean subdomains, my website's ovdan, and then you could have ovdanassets.com. You can think of the setup a bit like this. Then you could have cookie-free requests, which would reduce the header size and make it that much quicker for mobile. So let's connect to the server and make one of those. So let's go into the config directory and let's call it cdn.conf. And what we need to do is create a server block. And it's just going to listen on port 80. And it's not going to be the default, it's not a catch-all. So we need to give it a server name. Now I'm being lazy, so I'm going to use cdn.example.ovdan.com. And it's perfectly valid. I mean by lazy, it's that it's not cookie free. So any cookies that are on ovdan.com will be sent along with the request to this server. And we need to give it a root directory. So we'll create this directory in a minute. And we need to give it a location block. What I'm going to do is I'm going to paste this in here. So this is a location block purely for images and icon files and CSS, and there's JS in there. So what is it? Well, it's a regular expression match, and it's case insensitive. So if you put capital PNG at the end of your file, then it's going to be fine. Now it's looking for a dot. That backslash means it literally is a dot, not any file. And so we're looking for an icon. The pipe means OR, that vertical bar symbol. CSS, JS, GIF, JPEG, that question mark makes the optional. PNG, close the set, and dollar means that has to be the end of the URL. So these file extensions need to match at the end of the URL. And what we can do with this is we can actually say, tell Nginx to pass the headers that these files are valid for 30 days. So when the browser receives these files, then it can keep a copy for 30 days without checking again. And we can add the header. Public. And that's just to support older browsers. For newer browsers, we add the header cache control, and it's public. And that's the correct way. Now it's up to you what you do if the files don't exist. So what happens if somebody was to come to your CDN server and just go to /? Do you want it to show them a file, throw a 404? What? Well, why don't we be clever? Why don't we say, if the location /, then why don't we just say the root directory is var www html. And the index is index.html. And so we save that. We'll do Nginx reload. And now if we load up Safari and we type in cdn.example.ovdan.com, we've got a down for maintenance page. Oh yeah, we need to create the directory. So if we go into www and then make the directory cdn, and then why don't we copy the HTML ovdan logo into the CDN. Now you've got that image. Okay, let's turn on the developer toolbar and web inspector. What we're trying to do here is prove that it's worked by checking the headers inside the browser. But I can't see the content type or the expires header in there. So let's try something else. Let's copy that CDN image to ovdan.png just to be absolutely sure that it's serving the right file from the right location. It looks like our config hasn't worked at all, and it's just reverting back to the default server. So let's have a look at the config again. I've got a colon in there. So we go back to it always pays to do a config test. Okay. So config is okay. Let's reload. Let's try that image request again. That's different. It would have helped if I put that file in the right directory. Okay. Right. There you go. The file's there. And we'll check this. And there you go. You can see the expires header. And you can also see the cache control. So if you had an application that supported CDNs, you could just tell it that all your images and JavaScript are on this URL, this domain name. And under the hood, they could be anywhere. That route could just point back to your application directory. But it keeps your Nginx configs separated. So it's a lot easier to have a look at this and realize what's going on than having the default config and this, and then you end up with a large config file that's a little bit harder to read. Certainly when you're first starting out. And you could modify this. You could have your location block. You could have two lots of location block, one for your images, one for your CSS. Maybe you want your CSS to be cached only for one day, or your JavaScript to be only cached for one day because you're doing a lot more dev work on it. It doesn't really matter if the same image gets served, or an old image gets served, but old JS and old... It might matter if you serve old JavaScript or old CSS. Because you've updated the CSS, because you've updated your HTML, it might not work right. So maybe you actually want it down to 1 hour. At least you can change these values in here, duplicate it up, and do whatever you like. You could improve upon this. You could create a server per region, and DigitalOcean supports quite a few regions. And then you could use a DNS provider that supports proximity-based routing. That will allow you to redirect your user to a CDN in their region. If my server's in London and somebody's accessing it from, say, Australia, you could be adding like 1 or 2 seconds onto the request. Well, if they're waiting for the HTML and then they're waiting for the assets to come along with it, it's going to be quite a slow experience. But if it takes a second or two to get the HTML and then they can get the assets from their region, it's going to be a bit quicker. So it's just a thought. I'll see you in the next example. Nginx doesn't have a default way to handle dynamic content. But what it does have is a way to call FastCGI that can produce this content. An example of this is PHP. Though with a bit of work, it could be Python, Perl, or even C++. I'm sure there's many more that you could think of. The setup would look something like this. Hopefully you've installed PHP from the snippets earlier. If not, go back and do it now because you'll need it for this example. So let's connect to the server. And let's just double check we've got PHP installed. And we do, so that's great. And let's just change into the Nginx directory, or the Nginx config directory. And we're going to use the default file as a starting point. And let's edit that file. And we'll go with php.example.ovdan.com. And we'll change the index file to index.php. Let's not worry about these errors, redirects. What we do need is this. So what is this? Well, this is just saying if you're seeing a PHP file, proxy parse it. But actually, that's just the same thing. So if we see a PHP file, so anything ending .php, we'll pass it in. Don't need that. We'll literally pass it to FastCGI, and it's going to be listening on that IP address and that port. And that's just the default PHP comes with. And these are just some defaults. So this include file actually exists inside your Nginx directory, and it just defines a few variables for PHP. So it knows where the file is that you're working on, that's been called with, the directory, that sort of thing. Okay, so that is just that file. So we reload Nginx. What we also need to do is if we go over to the www directory and we make this PHP directory that I referred to, and inside, let's put it actually inside there, we'll create an index.php. And if I type in the URL .ofdan.com, oh, we've got bad gateway. Okay, this is the bit we need to double check on. So let's double check this. We're passing it to 127.0.0.1 and port 9000. We'll double check that PHP is also doing the same thing. And this is the default config for PHP. So let's scroll down. We're looking for a listen directive. Oh, they've changed the default. So by default, it's listening in a sock file. You could change this to an IP address, but actually personally I prefer the sock file. So we'll go back in over here. So we just need to tell it that it's a sock file. And then we just restart Nginx. If this doesn't work, it doesn't work. We just need to start PHP. No. So it's created the sock file. What does the error log tell us? This is a good reason to define your log file per server config. Okay, permission denied. This is so who's the listen user? Who is Nginx running as? If we have a look at Nginx conf, the user's Nginx, not www data. So we just need to make a quick config change. Let's change www data to Nginx. This is basically who has permission to access this socket file. So we save that. And then we just restart PHP. Now do we have access? Yes, but now PHP can't access the script. So let's just double check the logs one more time. So this is just where it's having trouble finding the file, which these variables were supposed to have sorted out. Let's go into the server config again. Right, this isn't going to help. Obviously in a previous lecture I moved the root out and I've completely forgotten to do it again this time. So obviously Nginx, in fact PHP can't find the file because we never actually set what the root was. So the default is going to be the Nginx directory. So that's not very helpful. Another reason this isn't working is because we've hard-coded in the scripts directory. Again, that's not going to help. So we need to tell it it's whatever the document root is. Now, hopefully, that is all we need to do. And we just reload Nginx. Hey! We got there in the end. But that's not PHP. That's just a file with the word hello in it. If we want to actually do PHP, then we need to do PHP. So if we just edit that file, and PHP just starts like this, and something that produces a lot of output to show that it's working is PHP info. It just tells you about the configuration. So we save that and we reload the page. There you go. Every single option in PHP, and it tells you what its state is. Obviously you can do a lot more with PHP, and I'll go over a little bit of it in the next few examples. In the last example, I showed you how to get PHP working, which is fine, but should we try a little bit more of a complex application? We'll try my password generator, which I wrote a little while ago, and we can get it to it on the internet. So the actual URL you're after is github.com/hackzilla/password-generator-app. But like always, I will link to it in the resources. Save you typing it out. And the quickest way to get it is if we type Composer create project. So let's connect to the server, and we'll go to var ww, and if I put another argument at the end, it will give us a directory. So if I call it generator, okay, to get this to work right, we need to install a few extensions for PHP, or modules as they're called. And what we need to do is type apt install php-xml, php-intl, and php-zip. And that'll install it for us. That should be quite quick. Great. So if now we rerun the Composer Create project, it should be able to download everything for us quite quickly. And there we go. So if we go into there, and as Nginx, we can type bin console cache clear and make it prod. This is a side effect of me installing this project as root using Composer. The binary files /bin are stripped of their executable privileges. Let's try that again. So what we were doing was we were generating the prod cache, and this just sort of helps if you do any updates or anything, the cache can get a bit stale. We shouldn't have had to do that because it was the first time we installed it, but it's safe. It's safer to do it than not. I think it's more a force of habit. Okay, so now we need some Nginx config to go with this. And we'll call it generator.conf. Now most of this you're going to be familiar with. So let's paste in the first part. So we've got a listen on port 80. We've got the domain name and we've got the root directory. It's all pretty standard. And then we just need to tell it how to serve the files. And instead of throwing a 404, we'll just route everything through to the index.php, because a lot of web apps run everything through a single file to generate all the files or generate all the HTML. And this is a PHP block that you can see it's looking for index.php, and it'll run it through the FPM socket. So it's all pretty standard. Now, this bit you haven't seen before is the environment variables. And this is a way of passing data into the application. So we're telling it environment prod, we're giving it some sort of secret, and it was after a variable called GA tracking. And if you needed to pass it a database, then this would be how you did it. But this particular application has no database, or no need for a database. And then we're just overriding the script file name here and the document root. And finally, to finish it off, if there's any other PHP, we just return a 404, because the only PHP file that we want them to execute is the index.php. And if we reload that, hopefully, actually reuse that window. We go to generator.ovdan.com or generator.example.ovdan.com. There you go. So it's quite happily working. And that's how you set up a more complex web app. I'll see you in the next example. Previously, I've spoken about how to install a web app, my password generator. Now, passwords are a sensitive thing, so we probably should be using encryption. And in fact, a lot of the internet is moving, or the general trend is everybody should be moving towards encrypting all their websites, from the banks all the way down to the blogs, because it just gives people a bit more privacy. So maybe we should set up this password generator with some encryption. Now to do this, I could just put it into the Nginx config directly. But what I want to do is show you how to create a HTTPS Terminator. So we're going to leave the generator running on the web host on generator.example.ovdan.com. However, just remember, this could be anywhere. This could be even local, so 127.0.0.1. This could be 127.0.0.1, or localhost, something that nobody else can get to directly, but they have to go through your Terminator to get to it. If you've got a web certificate, then, or an SSL certificate, then this is going to be easy. If you don't, and if you want to pay for it, then there's a lot of hoops you have to go through. There's a third option where there's a company called Let's Encrypt are giving away free certificates and a bit of software that, as long as the incoming connection can get to your server, then they'll validate it and give you a certificate for 3 months. And it will automatically renew for you, as long as the cron job's running, which is installed by default. To get this working, we need to install Let's Encrypt. So we go over to let'sencrypt.org. And what we need to do is get started. And this is their site to help you get going. So we're using Nginx, and we're using Ubuntu, but they don't seem to have the latest version. But no matter. So what we can run is this, because we've done this before to get actual Nginx installed. So that's the PPA. And then we need to do apt update. And then we also need to do apt install certbot. And that'll install a few dependencies for us as well. Right, so that's just telling us we need to start the service. So service certbot start. So what we're going to do is we're going to go into Nginx again, and what we're going to do is create another one called password.conf. And what we need to is we'll take this block and we'll call it password.example.ovdan.com. And instead of redirecting, because this one was in preparation of going to HTTPS, we change that and just give it the root of var www.html. Now the reason for this is the software is going to try and establish a connection between this domain name and the file system. So it's going to write something on the file system and then try to fetch it. If it's successful, it will give us a certificate. If it's not, then we'll be denied. So this is kind of like a get you started. So service Nginx reload. So we need to type certbot, cert only, webroot -w, and we'll give it bar www html. Now this directory needs to be a permanent home, otherwise you're going to have to change some configs. Pick somewhere that's not going to change. Maybe actually, let's give it certbot. We'll have to create it and set it up in a minute, but it's probably for the best. And we need to give it the domain name we want to secure. So we want password.example.ovdan.com. Yeah, so make that directory. And we also need to go in and double check and change this. Okay, so we've got the directory certbot, we're telling it certbot, and we need to give it an email address. Okay, so it's waiting for the verification. And congratulations, we've got a certificate. Perfect. If you don't have a certificate, you need to double check that that path is set up correctly. So you should be able to manually create a file in there and be able to access it. I'm going to actually change that config. And what we're going to do is we're going to put a location block in there for .well known. So that way when the location is rechecked, then it will go straight off into that directory. If not, it will then redirect us to the HTTPS version of the website. So if I try to go to password.ovdan.com, yeah, we're currently forbidden. How did I restart? There you go. So it's redirecting us to the HTTPS version. Now, if we go back into this config, because obviously we need to give it a bit more config. So we need to give it a HTTPS version. So we'll start that with another server block. If you're wondering what this : stuff is, this is it listening on an IP v6 address. We've also got HTTP2, which is the latest version of how web browsers can connect to the server, and this is just enabling it. But you need HTTPS to do that for most of the time. And obviously, this is the most important bit. We're telling Nginx that it needs to be in HTTPS mode or SSL. And then we need to actually give it an SSL certificate. And that is just going to be the name of the first domain name that you passed into that certbot. And then full chain.pem. And we also need to give it the key, which is going to be the same format. Password example.ofdan.com/priv key pem semicolon. We don't need to give it a root because we're going to pass it off onto another application. So actually the root is irrelevant. If you wanted to, you could put some access logs in. So you could do that. And the magic is in the last bit. So everything gets passed using a proxy onto the local host, but we also need to change that to port 80. So this could be anything. This could be another server, it could be a different port, anything. But we need to pass in the real IP address, which we could use at another date in time if we needed to. We need to tell it the host name we're trying to get to. So in this case, it's generator.example.ofdan.com. It could be that you want to use $host instead, and we want to pass in the same host name. So if you're moving from one server to another, then you would use $host here. And we're just saying it's been forwarded. Okay, let's save that and give that a go. Oh, that didn't quite work. It redirected us. So let's check and see what went wrong there. My favorite companion, curl. Password.example.ofdan.com, which has been permanently moved to HTTPS. Great. It's a good start. And for some reason that is redirecting us. But the good news, the HTTPS certificate worked. For some reason, this password generator doesn't like being inside a proxy. I can't figure out why. So what I'm going to do is I'm going to change it back onto the static website. And that at the very least will show it working. So we're just changing the host that we're trying to get to from the generator to example. We save that, and if we just Nginx reload, obviously because it's changed the URL, we're going to have to type it in again. So password.ofdan.com, password.example.ofdan.com, and there you go. We've got the little padlock. The URL hasn't changed. So the issue isn't with our HTTPS Terminator. The issue is with my Symfony application not liking the Terminator. And what happens is it's detecting this, and it's just changing the URL instead of complying and accepting this new URL. So at some point I'll update this lecture when I've figured out what is wrong with this particular application. But until then, this is how it will work for most applications. Just occasionally you'll run into this issue, and we'll figure out why together. I'll see you in the next example. I'm sorry about the last example where I tried to use Symfony and use the HTTP Terminator with it. Unfortunately, they improved their security so that if you try to proxy it and the hostname changes, then it's not going to honour it because it thinks it's a sort of an attack. So you have to tell it to let it through. So I finally got it working, as you can see here. And how did I do it? Well, all it came down to was a single line change. In the old version, or the current version, it honours all forwarded headers except the forwarded host, which is a shame. So what I've done is I've literally removed this piece, and I'm going to put it in the resources so you can just copy and paste it if you want to. There is another bit that you specify this X forwarded host header. The other config change you need to make is into the application to tell it that it's allowed to trust a particular proxy IP. So if we go back into the generator.conf, and if we scroll down, so here are environment variables that we've had previously, and it's this one that's important. This is a comma delimited list of IP addresses that Symfony will trust. And this is another piece of the puzzle. So we need to say that we're trusting it. We also need to say we're going to follow the host and it's not something nefarious. The other config change you need to make is into the application, and this is in the application that does the actual forwarding. But because we're telling it, or we've told it that 127.0.0.1 is a safe proxy, it's going to honour the headers. So this is that header. So with these two headers, it will work as long as you tell it that it's allowed to. I'll see you in the next example. We've seen how to proxy an application. What happens if one server is not enough? What happens if, to handle all the load, we need 1, 2, 3 servers? Well, that's where load balancers come in. Now, you can pay DigitalOcean $20+ to do this for you. And it might be a better solution, it might not. But for $5, you can build your own and get good enough. Especially as you can be in control of the HTTPS certificates. Whereas with DigitalOcean, if you want HTTPS on your load balancer, you need to point your DNS at them, which a lot of people might have problems with. I know I do, because I don't want to have to recreate my DNS. In that way, this is preferable. A load balancer allows you to scale your application traffic across multiple servers. So rather than we having one large VPS or droplet, which is mostly underutilized, you can have lots of little servers. In fact, you could have 1 or 2, and when you start to get more traffic, you can add more as required. And when the traffic tails off, you can remove them. This allows you to scale your costs based on your traffic. You can automate this, but it's beyond the scope of this course, as the implementation will vary depending on provider and application. Load balancing in Nginx is very similar to the previous example, the HTTPS Terminator. In fact, you could add the upstream from here and change the proxy pass of 127.0.0.80 to the proxy pass example server, and you'd be done. You'd even have HTTPS. So let's connect to the server. And we'll go into that config directory for Nginx again, and this time I'm going to call it balancer.conf. So we've got some upstream servers. These are the servers that do things. In fact, actually, we'll do it this way around. This works because obviously the catch-all domain name, and it also works because I've got the default website. It's going to be serving the static site, which is what we're going to load balance. So this is just defining them. So when I refer to example server, it's going to pick one of these. So we need to listen. And we're going to listen on port 80 on balancer.example.ovdan.com. And we're going to pass all traffic in through to one of these. And there you can see the example server. And that should just work. So balance example.ovdan.com. Yeah. And what we can do is we can set the header or set the host head. And if you remember my PHP domain, that will give us a lot of information. So in theory, we should start seeing that. So I reload balancer, and there you go. And in theory, in here, there should be a host.
And there you go. There's the host name.
So that is how you set up a very basic load balancer. I'll see you in the next example.